Hi all, have a good day. I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this video lecture, next topic which we will see is Ohm's law, which is very basic for circuit analysis. So before going into Ohm's law, we need to know some basics. First we will see what is an electric circuit. So electric circuit is nothing but an interconnection of various elements in which we will be having at least one closed path so that the current flow will be there. So current flow will be there only in a closed path. So the electric circuits are classified into two types based on the elements, which is the active elements and passive elements. So active elements are also known as sources and passive elements are also known as sinks. So active elements are nothing but the elements of a circuit which possess energy of their own and which can impart it to the other elements of the circuits. So under the active elements, we have two types of sources, voltage sources and current sources. So next we will see what is voltage source and what is current source. Current is nothing but the rate at which the electric charge flows in a circuit. So normally the charge will be flowing from low potential to high potential, or else we can say that the electric charge flows from negative to positive terminal. You can also say that current is the rate of flow of electric charge. Voltage is also called as electromotive force, which is the potential difference in charge between 2 points in an electrical field. So current source in an electronic circuit will deliver or absorb the electric current which is independent of the voltage. A voltage source is a two-terminal device which can maintain a fixed voltage. Next one is passive elements. These are the elements which do not possess energy of their own. Some examples of passive elements are resistance, inductance and capacitance. So resistance is nothing but the property of a conductor which opposes or limits the flow of current through it. The unit of resistance is ohms. So resistor is a circuit element which dissipates electrical energy usually in the form of heat. So some of the real world devices that are modeled by using the resistors are incandescent light bulbs which you use in our day-to-day life, and most of the stoves, heaters, etc. are all the real world devices which we are using in our day-to-day life which uses the properties of resistors. So resistance is measured in ohms. So we'll see what is a cell. A cell is one thing which stores the energy in the form of the chemical energy, and it converts this chemical energy into electrical energy when the circuit is connected. When two or more cells are connected together, we call that as a battery. The cell's chemical energy is used up pushing a current round a circuit. So in this following circuit shown here, can we guess how the current flow is done, from which direction to which direction? Yes, as already I told you, the current normally will flow from low potential to high potential. So here the current flow will be from negative to positive terminal of the cell. So consider the given simple electric circuit. So here we consist of mainly three elements, which is a cell, a switch, a lamp, and wires are used to connect all these three elements. So current flow will be only inside a conductor. So we'll be using metal wires to connect all these three components. So when the switch is on, or say when the switch is closed, then the current will be flowing through all the metals. There will be a continuous path, and therefore there will be current flow and the electric bulb will glow. If there is any breaks in the circuit, or when the switch is in the open position, or we will say when the switch is in the off condition, then there will not be any current flow and the bulb will not glow. So usually the circuits are represented in the form of symbols. So here the first symbol, which has a long line and a small line, shows the symbol of a cell. A cross mark with a circle represents a lamp, and the next one is a switch, and the red line represents the wires. So we'll see some basic symbols which are used to represent the elements in a circuit diagram. So these are all the symbols for different elements. As I said, cell is represented by a long and small line. Battery will be having two long lines and short lines alternatively. Then switch, lamp, buzzer, ammeter, voltmeter, motor, resistor and variable resistor. These are all the symbols generally used to represent the elements in an electric circuit. So next important basic law which is used in electric circuits is the Ohm's law. So it was found by the German physicist Georg Simon Ohm in 1827. So he described the measure of currents and voltages and also the relationship between them mathematically. So this relationship between the voltage and current was represented as Ohm's law. So Ohm's law states that the voltage across a conducting material is directly proportional to the current flowing through the material. Or else we can say that capital V is equal to R into I, where V represents the voltage, R represents the resistance and I represents the current. So the R is the constant of proportionality. So you can also represent this in continuous time of V of t is equal to I of t into R, or in general we can represent it as V is equal to I into R. So now another definition for Ohm's law is the temperature remaining constant, the current flowing through a conductor is directly proportional to the potential difference between the two ends of the conductor. So potential difference is nothing but which is the voltage. So we can say the current I is directly proportional to voltage at a constant temperature. So I is equal to V by R. R is the resistance of the conductor. So Ohm's law can be applied for both AC and DC circuits. There are certain limitations of Ohm's law. So Ohm's law can be used only for metallic conductors. It does not hold good for non-metallic conductors such as silicon carbide. Also, Ohm's law is good only for linear devices, and it does not hold good for non-linear devices such as Zener diodes, voltage regulators, etc. Next one is power absorption. So power is an important factor in any circuit. So the product of voltage into current gives the power. So the V and I are selected to satisfy the passive sign convention. The absorbed power appears physically as heat or light and is always positive. A positive resistor is a passive element that cannot deliver power or store energy. So the expression for power is equal to V into I, or we can represent it as I square into R or V square by R. Hope you have understood Ohm's law. So let us take some of the assessment questions. So in which of the following cases is Ohm's law not applicable? Electrolytes, arc lamps, insulators, vacuum ratio values. Yes, we know that Ohm's law is suitable only for metallic conductors. So it is not applicable for insulators. So the answer here is insulators. Resistivity of a wire depends on length of the wire, cross section area, material, all of the mentioned above. Resistivity depends only on the types of materials which is used. Ohm's law is not applicable to DC circuits, high currents, small resistors and semiconductors. Yes, the answer is Ohm's law is not applicable to semiconductors. Thank you for watching this video.